We shall start with a new topic called functional dependence and independence. First we will see what is functional dependence. If the functions u and v of the independent variables x and y are functionally dependent, it means u and v are functionally dependent on x and y, then the Jacobian dou of u comma v by dou of x comma y is 0. It means dou of u comma v by dou of x comma y, the Jacobian is equals to 0. Then we can tell that u and v are functionally dependent. Otherwise, u and v are functionally independent. It means if dou of u comma v by dou of x comma y is not equals to 0, then we can say that u, v are functionally independent. So this is what functionally dependent and functionally independent. We shall see a problem here. If u is equals to x plus y by 1 minus xy, then and v is equals to tan inverse x plus tan inverse y, then prove that u and v are functionally dependent and find the relation between them. So they given the functions here u and v in terms of x and y, and then we have to prove that u and v are functionally dependent. So u and v are functionally dependent means we have to prove that dou of u comma v by dou of x comma y is equals to 0. Then after we have to find out the relation between them. It means relation between u and v. So here the first u is equals to x plus y by 1 minus xy. Let it be as equation number 1. And v is equals to tan inverse x plus tan inverse y. Let this be as equation number 2. So now we have to differentiate u function with respect to x and y. So first we are differentiating with respect to x, that is dou u by dou x is equals to dou by dou x of the function u x plus y by 1 minus xy. So here u by v, we have to apply the method u by v. Then it comes as first denominator square, that is 1 minus xy whole square, and in numerator first v is this is in the form of u by v. So now v is multiplied and u is differentiated with respect to x. So write v as it is here, 1 minus xy, and then this function is differentiated here with respect to x. So x plus y differentiated with respect to x, then x differentiation with respect to x is 1 and y differentiation with respect to x is 0. So here 1 minus xy into 1 plus 0 and minus, now x plus y is treated as constant and denominator term is differentiated. So x plus y into 1 minus xy is differentiated with respect to x. So here 1 constant differentiation is 0 and minus xy differentiation with respect to x is y. So here when we are differentiating with respect to x, y is treated as constant, so that's why we have written y here, and then it is multiplied with x differentiation with respect to x, so that is 1. So y into 1 is y, and here that is 1 minus xy into 1 plus 0 minus of x plus y of 0 minus 1 y by 1 minus xy whole square. So now here it comes to the multiplication. Here 1 minus xy and minus x into minus y, that is plus xy, and minus y into minus y, that is plus y square. So divided by 1 minus xy whole square, and that equals to, here plus xy minus xy and plus xy gets cancelled, then the remaining is 1 plus y square. So that is 1 plus y square by 1 minus xy whole square. This is dou u by dou x. Then here dou u by dou y, that equals to dou by dou y of function u x plus y by 1 minus xy. Same we have to apply here u by v method, u by v rule, that is now here it's divided by 1 minus xy whole square, and in numerator it comes as 1 minus xy into differentiation of x plus y with respect to y. X differentiation with respect to y is 0 and y differentiation with respect to y is 1. So 1 minus xy into 0 plus 1 minus, now numerator rated as constant, so x plus y into denominator term is differentiated with respect to y, that is 1 minus xy is differentiated with respect to y. So constant derivative with respect to y is 0 and minus xy differentiation with respect to y is x. So that equals to 1 minus x into minus x is plus x square and minus y into minus x is plus xy divided by 1 minus xy whole square. Now minus xy and plus xy get cancelled and remaining is 1 plus x square, that is 1 plus x square by 1 minus xy whole square. Then we have to differentiate the function v with respect to u and x and y. So here dv by dou v by dou x, that equals to dou by dou x of the function v is tan inverse x plus tan inverse y. So here tan inverse of y differentiated with respect to x. So as there is no x variable in this term, then its differentiation becomes 0 here. Now tan inverse x differentiated with respect to x, so its differentiation is 1 by 1 plus x square. So tan inverse x differentiation with respect to x is 1 by 1 plus x square, plus 0 is again 1 by 1 plus x square. So this is dou v by dou x. Now here v is differentiated with respect to y, that is dou v by dou y, that equals to dou by dou y of tan inverse x plus tan inverse y. Now tan inverse x differentiation with respect to y is 0 and then tan inverse y with respect to y is 1 by 1 plus y square. So this is dou v by dou y. Now we have to find out the Jacobian. We have the formula here, dou of u comma v by dou of x comma y. This equals to determinant of dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. And that equals to, write the elements here. Dou u by dou x we got it as 1 plus y square by 1 minus xy whole square. And dou u by dou y is 1 plus x square by 1 minus xy whole square. Dou v by dou x is equals to 1 by 1 plus x square and dou v by dou y is equals to 1 by 1 plus y square. So we have written the elements here. Now it comes to the determinant part. Find out the determinant here. Like a, b, c, d, we have to find multiply these two minus of these two elements. And that equals to 1 plus y square by 1 minus xy whole square is multiplied with this element 1 by 1 plus y square. So it becomes 1 plus y square by 1 minus xy whole square into 1 plus y square. So in numerator term and denominator term gets cancelled here. Then minus 1 plus x square in divided by 1 minus xy whole square is multiplied with 1 by 1 plus x square. Then here we get 1 plus x square by 1 minus xy whole square into 1 plus x square. So as here also the numerator term and denominator term gets cancelled. Then finally it comes as the 1 by 1 minus xy whole square minus 1 by 1 minus xy whole square. So plus term and minus term, this it equals to 0. So finally we got 0. Dou of u comma v by dou of x comma y is equals to 0. Then we can say that u and v are functionally dependent. Hence proved. So here we have proved whether it is a functionally dependent or independent. And now it comes to the relation. We have to find the relation between u and v. We know they have given that v is equals to tan inverse of x plus tan inverse of y. So we know that tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y by 1 minus xy. This is a standard formula. So when we apply here, so this can be written as tan inverse of x plus y by 1 minus xy. Then v is equals to tan inverse of u. So from equation 1, from the starting equation, u is equals to x plus y by 1 minus xy. So from that we can tell that this can be written as u. So v is equals to tan inverse of u is a final relation between u and v.